Howdy there, it is your favorite geometry teacher, Miss Elliott, and today we're going to be working through the Unit 3 review. Today we are just working on the we do section. This is your responsibility to do the you do section, and when I tell you that this review is gold, it is just like your test. It is a very good review. So the more you put in, the more you will get out of it. So let's begin with number 1. One thing that we should know is the triangle angle sum theorem. The idea that the angles in a triangle, x plus 4x plus 65, are going to add up to equal 180. And so first thing we need to do is combine like terms. The x plus 4x is going to combine to make 5x. So we have 5x plus 65 equals 180. We can subtract 65 from both sides and find that 5x equals 180 minus 65, which is 115. We're going to divide both sides by 5, and x equals 23. So here we have equilateral triangles, and we don't know that just because the title tells us that. It's because we see two 60s. Anytime we see two 60s, we know that the third is 60 as well, and all sides are congruent. And so since congruent means equal, we're going to say 5x minus 9 is equal to 36, and solve for x. To solve for x, since this says minus, tenemos que hacer la opuesta. We have to do the opposite, plus 9 on both sides. And we get 5x equals 45 divided by 5 on both sides. And we find that x equals 9. Now, the first thing you should notice for number 3 is that this triangle has two congruent angles. And since this triangle has two congruent angles, that means it's going to have two congruent legs. This leg and this leg. And so since congruent means equal, once more we're going to set up our problem, part equals part. 7x minus 4 equals 6x plus 8. Whenever we have x's on both sides, we're always going to start by subtracting the smaller x. So which is smaller, 7 or 6? Our smaller x is 6x. These 6x's cancel out, and I'm left with x minus 4 equals 8. I need to add 4 to both sides, and we find that x equals 12. So what is the exterior angle theorem? The exterior angle theorem is outside equals inside plus inside. Meaning outside 4x minus 7 equals inside 7x minus 25 plus inside 4x minus 31. Our first step is we need to combine like terms. 7x plus 4x is going to make 11x. And negative 25 and negative 31 is going to make negative 56. and we have 4x minus 7 equals 11x. Now we're right back at that same position that we were in the last problem, where we have x's on both sides of our equal. Anytime we have x's on both sides of our equal sign, and there's only one on each side, then we have to subtract the smaller x. So now I have negative 7 equals 7x minus 56. Just going to skip this area right here, and in fact, I'm just going to move this down a little bit so we can see our work clearly. It's time to add 56 to both sides, and negative 7 plus 56 is going to be 49. 49 equals 7x, divide by 7 on both sides, and we find that x equals 7. So here's our next problem. Something that we should recognize about these triangles is that these triangles are congruent by side, angle, side. So if they're congruent by side, angle, side, then their corresponding parts are congruent as well, because corresponding parts of congruent triangles are congruent. So these sides are going to be congruent. And again, congruent means equal. Therefore, 4x plus 6 is equal to 6x minus 12. We're going to subtract our smaller x. These cancel out. I have to bring down the 6. Always working from left to right. 6 minus 4 is 2x minus 12. Now we can add 12 to both sides. We get 18 equals 2x. Divide by 2 on both sides, and x equals 9. Now, if I asked you to find the length of this side, what is the length of this side? Well, it's 4 times 9 plus 6. So here's your hint that on your test, you're going to be asked to do more than just find x. There's going to be a problem where you're going to have to go and take your x and plug it back in. So now we have vocab. Determine if these statements are true sometimes, always, or never. An equilateral triangles are acute. So if we know our equilateral triangles really well, then we know that they look like this. We know that each angle is 60, and they're all the same. And if we know that acute means less than 90, then is this true sometimes, always, or never? I really hope you said always. An isosceles triangle, so we need to know what isosceles means. Isosceles means two congruent sides. Is right. Has a right angle. If you remember your quiz, I put an isosceles right triangle on your quiz in hopes that you would understand that, yes, sometimes an isosceles triangle is a right triangle. The acute angles of a right triangle, so let's talk about those. Here is a right triangle. And so if I'm talking about the acute angles, I'm talking about this angle and this angle, are complementary. Complementary means adds up to equal 90. So we have to think about, what do all the angles add up to be? All the angles add up to be 180. And 180 minus the right angle, 90, leaves us with 90. So the other two have to add up to equal 90. So this is always true. Let's move on to number 7. In triangle FGH, angle G is 90 degrees, side GF is 16 inches, side FH is 23 inches, and side HG is 16 inches. I notice that 16 and 16 match. I also see that we have a right angle, so classify it by its sides. When we classify by sides, our options are isosceles, scalene, or equilateral. When we classify by angles, our options are acute, obtuse, or right. And so it looks like this triangle, since it has two congruent sides, it's isosceles. And since it has one 90-degree angle, then it's also a right triangle. So this is an isosceles right triangle. And if I were to draw it out, it would look something like this. Here's G, 90 degrees. We have F, G, H. This is 16 inches. This is 16 inches. And this is 23 inches. I highly suggest that on your test you draw a picture. In triangle TYU, angle T is 60 degrees. 60 is a special number. TY is 16 centimeters. YU is 16 centimeters. And TU is 16 centimeters. All the sides are the same. So what type of triangle is this? This is an equilateral, acute triangle. Or more accurately, you could say equilateral, equiangular